All right. So this lecture is titled Advanced React. It probably should be more titled something along the lines of debugging / other React things that didn't fit into the first two React lectures. So this will sort of just be a mixed bag of just random React stuff that I thought might be interesting or useful to know. Pretty free form, loose. Feel free to ask questions in the chat on this one if you want to. So the first thing I'm going to show you all is something called dog generator. So this was built by, I believe, Nick and Shannon last year when they did this lecture. And it's just a very simple web application that we use to demonstrate some slightly more advanced or other React like things. So the way dog generator works is when you load the page, it shows your little dog bed. And then when it finishes, you get your dog. Incredible. And you can type in all sorts of dogs. So like Labrador would be my favorite. Amazing. And then Chihuahua, for example, they're nice, but you can see the goodness meter went a little bit down for the Chihuahua. And then if you do something that isn't a dog like Nico, we just end up with a picture of Nick, which is a little disappointing. But for the most part, we just get dogs. Okay, so that's dog generator. That's what I'm gonna use to demonstrate a few different things here. The first thing I'm gonna demo is actually something pretty simple called the children prop. And so this is like a special prop in React that we haven't, I don't think we've explained this to you all at all during Web Lab so far. But basically the way the children prop works is in the case that you want to reuse some logic that wraps a different component. So the example I'm going to use here is a card, right? So let's say we want to enclose, okay, so in Catbook, for example, all of our posts are enclosed in some styling that you might call a card, right? It's got this nice outline. It looks like it pops out a little bit from the page. Let's say we wanted to do something like that on dog generator or whatever web application, but we wanted a separate card for different parts of the application. So maybe we want an actual component, because the whole point of React components is that we can reuse them everywhere. So we can create a component called the card component that actually lets us reuse the logic. Is this big enough for everyone? Hopefully it is. I see a couple of thumbs up, so, and nobody's telling me to make it bigger, so we're good. Oh, okay, let me get a little bit bigger. Cool. So what this is just another React component, just like any other class card, extends component. And the way this works, we don't know. It's a very simple component. All it does is it returns a div around a special prop called this.props.children. And what this.props.children actually refers to is any child component of this one. So if you remember in HTML, we can sort of wrap components in each other, right? Like everything here is inside of this div. We can do the same with React components once we use the children prop. So let's say I wanted to wrap this good boy meter. So the good boy meter refers to this meter right here. Let's say I wanted to wrap that in a card. I can just use the card component that I defined earlier. And then I can pop the good boy meter inside there. And now the good boy meter is in this beautiful little card container here. It pops out from the page. Yeah, Johan, this is, or Vic, this is like a custom OMyZSH thing that I stole from someone online. Now, because it's reusable, we can reuse this card component here, this, and suddenly we have cards on both of these, on both the good boy meter and the dog breed itself. Such good boys. Okay. So the whole point of this is we can use the children prop, very simple, to allow components to wrap other components in logic. Okay, let's go back to the PowerPoint for a second. So in reality, for something as simple as the card wrapper, you would actually just probably want to use a utility CSS class to do this. I feel like we talked about utility CSS classes in the CSS lecture, and you can just apply the same class to multiple different components. But wrapping components like this can actually encapsulate a lot of more complex logic. So for example, loading data, let's say a couple different components need the same data, and you don't want to write the get component did mount, dot then, set state, all of that stuff multiple times. So instead, you could write a single wrapper component and use the children, and you would pass as a prop the data that you fetched to the child. But the way you'd more often do that is something called higher order components, and you might see this on the internet. But all HOCs is basically the same as using the children prop, but you do it as a function. So here we're just exporting a function. This is the same logic as the card function, and it'll do the exact same thing as the card. But instead of being a component that you use the children prop and you wrap it, here we just call it the wrap with card function. And then we call the function on this component and it wraps it with some additional information. In this case, the card CSS classes around a div. And you could also do this HOC thing with data fetching. So maybe your component here, whatever this function returns, actually does the data fetching. So there's some other use cases. You could make an HOC that logs props as things come down through it. You could do data fetching. That's what I mentioned earlier. And that's actually exactly what Facebook was showing you all in the Facebook workshop. When he showed with GraphQL, he used an HOC called create fragment container. And all that does is it does the data fetching in the background using GraphQL and then passes it down as a prop, wrapping the component. So anything where you might use inheritance in another language in React, you're probably going to want to use HOCs. Now, most of your websites are not going to use HOCs. This is just an interesting thing that you will see if you go to, for example, if you do an internship at any company that uses React, you're probably going to see HOCs at them. Okay, now we're going to jump into a few sad reacts. Oh boy. Sad reacts are things that you do not want to do in React.js. We will be sad if you come to office hours and you have bugs that have to do with these things, because we are explicitly telling you in these lectures that they make us sad. Please do not do these things. Okay, the first one's actually a little bit more complicated, so we won't actually be sad if you do this. Okay, let's say we have like an input, for example, in dog generator. We have an input box here. We type something and we want to get the information from that input box and use it in our request, our get request in this case. Okay, so this is what that might look like. This is exactly how it looks in dog generator. Actually, there's an input and then there's a callback. So every time a key gets pressed, this function will get called on key down. Key code 13 is just saying if there was an enter button pressed. And then what we want to do here is we actually want to make a request to a different website that has a list of dogs. And we want to get the photo of the dog from that website. That's what dog generator does. So how might we do that? Well, if you remember the snake lecture, before we learned React, you might think, okay, we could just use document.getElementById, right? What this does is it goes through the entire HTML document and it finds the only element that has a particular ID. So can we use that to find the information that is sitting in here? In this case, in that input element? Yeah, I mean, technically, yes, you could do that. Should we use document.getElementById? No, the answer is no. The reason is that IDs are unique. And if you remember this from our HTML lecture and CSS lecture, I think the very first day of Web Lab, since IDs are unique, we don't want to use them in React. The whole point of React is so that we can create components that have reusable logic. And in React, as soon as you start using IDs, then you can't ever have two of that component. So it really messes up the reusability, and you can end up with real weird bugs that the staff will have trouble debugging. So lesson, do not use document.getElement by ID to get information from a form in your React applications. Okay, so how do we do it? Well, this is how. We're going to get our breed through something called event.target.value, or this is one way to do it. So whenever this onKeyDown function gets called, remember the browser is the one that actually handles this. So every time a user presses a key button, then the browser actually calls your onKeyDown function with the right key code, but with something called event. And what event does is it tells you exactly what happened on this event. So in this case, we can use event.keycode to tell us that it was the enter button. And we can use event.target to tell us where the event happened. And that's the important part for this input element. In this case, this event.target is going to refer to that input element where the person pressed the enter button on. So event.target is referring to this particular input element. So when I type Pembroke, I press enter, event.target points to that, and then event.target.value will actually be the value that is inside that input element, inside that text box. And then we can just update the state using the breed as you normally would in React. Okay, so what if event.target isn't the element we want? So for example, what if we want to, on button press, submit a form? So let's say there's a button over here, then event.target, if we click on the button, will refer to the button, not to the input. So that might be a problem because event.target is referring to the wrong thing. We can use two different ways to do this here. Number one, and what we're going to recommend, is controlled components. The way this works is you synchronize the input values with the React state. So the value is always available to read. You update the state to modify the value. So what that means is that every time someone presses a key in that input, we call this .setState, and we update the state in your React component to match whatever's in the input box. That keeps the React state always in sync. So no matter what happens, you will have that input value available to you in React in state. Vic asks if we can get other info about the target. So in this scenario, when you have event.target, yeah, event.target literally just is a reference to the input element and whatever other information you need about from that input element you can grab. Vedanta asks if you can have variables that are not in state. Yes, you can have variables in React that are not in state. However, they will not get maintained between different render calls. And I'm not explaining this well, but what that means is that every time you call setState, the component re-renders. And so variables that are not saved in state will get lost. Okay, because the render function gets called from scratch every time that the component re-renders. Cool. The other way you can do it is through something called refs. I'm not going to really talk about these because they're a little bit confusing, but just in case some of you are more interested in even more advanced React stuff, there's something called a ref that keeps a reference to the DOM node, the HTML node that corresponds to a particular component. You can save that ref and you can access it later in ref.value. Okay. So any questions about controlled components or how that kind of situation works? So we've got two different alternatives. Don't do document.getElement by ID. Instead, you should use event.target.value like this, or you should use a controlled component that looks more like this. Cool. And then, yeah, we saw dog generator. Okay. Next thing I'm going to show you guys briefly is something called the React Developer Tools. So everyone who is watching this and who has not already done this before, you should actually just go to this link right now. Or in my case, Firefox. Go to weblab.2/chrome-dev-tools or firefox-dev-tools. You should install these. They are very helpful. I am now going to show you why they are helpful. Okay, dog generator is not a good example here, but so I'm actually going to pull up Catbook. I think I have Catbook running, so Catbook is a little bit of a better example for these React Dev tools. And these React Dev tools do not zoom for some reason, so I'm going to change the way I'm sharing my screen for you to hopefully see a little bit better. Okay. Can everyone see that okay? Hopefully. Yes, I see a couple of thumbs up. Okay. So what we're hitting here is I've hit F12 or inspect, whatever your favorite shortcut is. I think Control-Shift-I works too. And then once you have the developer tools, the React Dev tools installed, previously we've used this, I think. We've used the console where we can run JavaScript code here. There's other tabs that are helpful, but the React Dev tools adds these few tabs off on the right called Components and Profiler. The most important one is probably Components for you all. And the nice thing here is it literally just gives us a way to visualize our component tree. So if you remember from the beginning, we've been showing you these component trees that we've written out manually in PowerPoint, but this gives you literally just, it shows you the component tree. So in this case, the nav bar has 2 children, 2 links. If you're not seeing components or profiler, you might need to restart your browser, or you need to open an application like Catbook that actually uses React. So we've got our little React component tree here, pretty beautiful, but then even better and even more helpful, we can actually see all of the props and state of any particular component. So let's say I click on app, I can see that it has no real props and it has a single state, which is user ID. Now, if I log in, we can actually watch user ID go from undefined to my user's ID. It's pretty cool. It updates in real time. So any of these other ones, you can see the props, you can see the state, super helpful for debugging. Highly recommend using this if anything in your UI is not working as you expect it to. So let's come up with actually a quick use case for this. So I'm going to check out a different branch real quickly. So let's say we're on dog generator, and for whatever reason, instead of giving us our Pembroke or our Labrador or a Chihuahua, or if any of you have your favorite dog breeds, feel free to send them in the chat. Instead of giving us those breeds, it's just giving us Nick. This is really disappointing, really, really disappointing. So what are we going to do about this? Well, what we can do is we can open our beautiful React Dev tools. We can go through our components list. We can see, okay, the app has the correct breed listed here as Chihuahua. I know this is small, but I can't really make it bigger for you all. Our good boy meter has the correct breed, Chihuahua. Our dog viewer has the correct breed, Chihuahua. Oh, wait. There's 3 E's in that breed. And there is our bug. No, oh, wait, what? Why does control scroll work? But control plus minus doesn't. What the heck? No, you're a genius. How do you know that? That is wild. Okay, now you should all be able to see this. The breed is correct here, but we can see here that there are 3 E's in that breed. That is a problem. Let's go back to our code. And what do you know? There are 3 E's where we pass it our prop here. This is a super common bug to misspell props like this. So we can change that. And we get our Pembrokes back. Wonderful. Beautiful. Just lovely. Okay. Any questions about the React Dev Tools while I'm here? Oh, I guess I was going to show you one other thing. So I have to go to Chatbook to show this one. So this is the profiler in React. And what this does is it actually helps us figure out where performance problems are in our React application. So let's say I'm typing in all chat and I send a new message. And let's say for some reason it's really slow to send that message. Okay, it's really fast, but like let's say there's something slow in your application. What we can do in the React Dev Tools is click this little record button, start profiling. We can send a message, and then we can stop profiling. And what we actually see here is a list of all of the renders that React did while we were recording, while we were profiling. So I can scroll through each of these renders and we can see that all of these renders were super, super fast, less than 0.1 milliseconds, which is pretty sweet. That's pretty good, very good performance. And then I see this one big render here. Holy cow, look at how tall that bar is. That's a fat boy. Okay, so that render took a while. And when I say a while, I mean 29 milliseconds, which is not actually a long time. Although, to be fair, if you want your application to run at actually 60 frames per second, I think 1/60 comes out to 16 milliseconds. So 29 milliseconds actually would be less than 60 frames per second. So if you're running a game, this could be bad for performance. Whatever, point being, this one took way longer than the rest. What exactly is this render? Well, it turns out that render was actually the one when I pressed submit and it re-rendered all of the messages. And we can see here that it rendered all of the messages because we see a whole bunch of messages here that each took a millisecond to render. So this graph here is called a flame graph. You may or may not be familiar with this style of graph, but it's basically saying that in this tree of components, the app didn't re-render, router didn't re-render, Chatbook re-rendered, but Chatbook itself took only 0.1 milliseconds to re-render, and then etc. all of this stuff. I don't actually know why it re-renders the message. I didn't look into the performance. Let's look real quickly. Let's look at Chatbook. This is a bad idea probably because I didn't look at this before while I was preparing this lecture, but that is a good question, Vic. Do any of the staff know why it's re-rendering all of the messages, especially the ones who worked on Chatbook yesterday?
Check what the API endpoint returns.
Well, it should just be sockets. So it's because the render function here just has a, like, if you go into chat itself, it should be mapping all of the chat messages into React components. And so it has to re-render all of them. But if they had children, then it wouldn't like deeply re-render those.
So I wonder if the reason is because we're using the index here as the key. And so React doesn't know which is which, and so it just has to re-render all of them.
Except that the index is actually constant in this case.
Oh, that's true because it's append-only chat. Okay. Either way, point of this point is that we can see from this what is re-rendering and what might be causing your application to be slow, and from there you can go and debug. It might take longer than I have to spend on this part of the lecture, though. But feel free to come to office hours if you need help. If you need help figuring out why some part of your application is re-rendering. There's also stuff I can show you later on, if I get to it, called use memo and use callback that will help you and pure components that will help you not have things re-render and not take a long time to re-render. React can sort of save their content. Okay. Any other questions about the dev tools before I move on to the next stuff? Okay. So yeah, we can visualize the component tree, we can debug, we found a bug using the dev tools. And we can figure out lots of performance things. Okay, let's move into some more sad reacts. These are the things that we're actually going to be sad if you come to office hours and ask us to debug, because once again, we're telling you not to do these things right now. Please do not copy any of your props into state. So this can sometimes be tempting in your constructor when you initialize your state. You might want some prop to initialize that state, and you might want to then modify that state later. Do not do this. When you copy props into state, what it effectively means is that you have state held at two different levels in the React tree. So if it's a prop somewhere, it's probably state somewhere higher up. And so if you also make it state in your current component, you now have that state held in two different places, and nothing in React keeps those in sync because you only did it on initialization. So this can lead to really hard to debug problems because you have that state that can be different in two different places. The dev tools can help you debug these kinds of problems, but just don't do it. Just don't copy props into state. There are other ways to do this. Have a single source of truth for your state. And if you really need to modify things that are higher up, then you can pass a call back down to update it. If you make a state and pass it as a prop, it will update in the child as well. Not if you do this copy props into state thing, but like if a state is higher up and then it gets passed as prop, it will update all the way down as long as it stays as a prop. Do not make it into state at a lower level though. Please do not use indices as keys. I know I literally just showed you code that does that in Chatbook. So in this case, the reason why this is technically okay, as Nick explained, is because the chat is append only. So I'm just going to put the blanket statement here, use indices as keys. Do not do this because it's pretty easy to do this wrong. For example, in our to-do list application that we gave you all as homework during the first week, it had bugs because of index being used as key. And maybe one of the staff can remind me if this turned out to be an actual bug or not, I don't remember. But basically React relies on the fact that keys are going to be unique per item. And so it assumes if two items have the same key, that they are the same item. And it can make performance optimizations based on that assumption, which means that if you use index as the key, and then you sometimes like modify which item has which index, React can actually get confused when it tries to optimize performance and can actually render the incorrect thing. Okay, so don't do this. Please do not forget to prefix your class names with the component name. Okay, we showed you this when we first introduced React, but if you remember, everything that's in Catbook, whenever we do a class name for CSS, we prefix it with the name of the component. So chat-container, chat-history container, because this is all in the chat.js and the chat component. Now, the reason we do this, and I think we explained this when we initially talked about components and class names, the reason we do this is because CSS in React is global. So even if we have a particular file like chat.css, if these names are duplicated in any other components, then those styles are going to get applied to those other components. So even though you only import chat.css into chat.js, those styles apply to the entire component tree. So that's why we need to prefix our class names with the component name to make sure that these things match up. I think I spent like 30 minutes, 45 minutes debugging this issue with a single group in office hours last year. That might have been Claire's group, I don't remember. Okay, please do not use .bind. We showed you use arrow functions. When you use arrow functions, we don't need to use .bind. Not trying to call you out, Claire. We didn't have this in the slides last year, so I'm not blaming you. .bind can cause weird bugs, so just don't use it. We're going to be annoyed if you come in with code that has .bind. Do not put more than one component in a file. So let's say I'm in my React Dev Tools and I'm clicking around and I see, I guess this is one other feature of the React Dev Tools I didn't show you. I can click this little guy here and I can go here. And then you'll see that it's called new post input. Okay, that's not actually what I was thinking. Let's go. I'm going through my component tree. We have new post input. Now that works. Why does that work? Why does it not say new story? Oh, okay, sorry. Let's say we go to our React component tree. We see new story and we're like, okay, this is a new story component. Let's find the code for new story. And I hit Control P in VS Code and I look for new story. There is nothing. I get confused, I get sad, I give up, we lose WebLab. What we should do is we should have named all of our components by their names. So there should be a new story.js so that I can just type new story and find it. In reality, new story is in new post input.js, which is confusing. Don't do that. Yeah, Tommy, Control Shift P. Wait, Control Shift P? Why does that just open this? Do you mean Control Shift F? Okay. That does work, but it's much more annoying because new story shows up in like 3 different files. Okay. Point being, just put your components one per file. It's not that hard to do. Okay, let's start speeding a little bit because I'm running low on time. Reading error messages. This is a quick piece of information. A lot of people in WebLab will come in and reading error messages is hard because when you get a message like this in your console, then you end up with a huge wall of red text and all of this stuff is confusing. What the heck is begin work $1 React DOM development? Should I know what that is? Should I worry about what that is? The answer is no. You don't need to worry about 99% of the error message here. And this is something just more of a general tip in computer science. Usually there's a particular part of the error that is pertinent to your particular problem. So in this case, you can probably figure it out since it's sitting right at the top. All of these other things are irrelevant. The only relevant part here is uncaught reference error, dog viewer is not defined, and it gives you the line of code in which that occurred. So that means that we forgot to import our dog viewer. Pretty simple error, but the error message looks really intimidating and hard to read. But just know that with this type of error message, you're just going to want to look at that very top part. Dog viewer is undefined at app line 43. Cool. Another error message where, again, there's a huge wall of text and you may or may not know. Fortunately, this one's helpfully colored to tell you what the important parts are. All of the white text is totally unimportant, but the colored parts are important. But the real error here in this whole wall of text is just the fact that you forgot to return a single component in render. If you remember from the React lecture, each render function has to return a single outer component. In this case, you might want to use JSX fragments using these little empty tags to fix that kind of bug. One other problem, React attributes are sometimes named differently from HTML attributes. So if you are searching up in MDN and you find some attribute on an HTML element, every once in a while, they're going to be named slightly differently for React. In this case, for has to be renamed because for is a keyword in JavaScript. It's for a for loop. And so in React, it's called HTML4, which might be different from the HTML version that's just for. All right. I was originally going to talk about context here, but we don't really have time. Context is a thing that allows you to avoid prop drilling. I'm not going to go over it in detail, but just know that it's something that exists. So we're not going to show you in detail, partially because it's easy to do it wrong and easy to make React really inefficient when you're using context. A lot of context lets you pass information way down the tree and skip a bunch of levels as props. But that can cause React to not know how to optimize well, so you should use it rarely. So just know that that's something that exists. If you find yourself passing a prop down like across like 10 different levels of components on the way down in your component tree, you might want to look into using context. Okay, now we're going to jump into something called function components. So you might have seen this if you've done some Googling about React. Not all components in React anymore are defined in a class. So we've taught you up until now that when you write a component, it should be class, component name, extends component, and then the curly braces, and then you need your constructor, and then you need your component did mount, and you need your render method. Okay, function components do this all differently. So this is the general form of a function component. This might look generally familiar. This might look like just a render function, right? Oh yeah, that's a good point. This is an example taken from the React website, so it doesn't use an arrow function. You should still use an arrow function. I'm sorry, Nick. But most of this should look familiar. We're still returning HTML and JavaScript in the same way that we would in a normal component. The difference is that it's a single function instead of how we've done before, a class and then a render function in that class. So these two are actually equivalent. A class that extends React.component and you return this is the same as welcome, just as a plain function that returns this. Why we use arrow functions is because actually the main reason we use arrow functions is only relevant in classes, but just use arrow functions everywhere because inside classes, arrow functions have much better behavior. And so we don't want you to get into the habit of using anything except arrow functions anywhere. Okay. So now we've shown you what generally it looks like to do a function component. We're going to now convert dog generator into function components. Dog generator is a pretty simple application, so this shouldn't be too hard to do. Okay. So hopefully everyone can see this. We're going to convert dog generator into function components, component by component. And we'll find some of the advantages of function components along the way. So we're going to start with good boy meter. The way good boy meter works is it literally just takes a prop that is your breed. And then depending on which breed it is, if it's a good breed, it gets a full bar. If it's a bad breed, it gets a very low bar. Otherwise, it gets a medium bar. So if we want to convert this to a function component, all we have to do, we can actually delete the constructor altogether. You don't need constructor and function components. We can actually delete the class statement and replace that with const. And then we're going to do arrow functions. And the props come in as an argument to the arrow function. So now we're going to delete the render function. And suddenly we have a function component. That wasn't too hard, was it? Good boy meter went from a class to a function component. Nice and easy. Only a few lines of changes. But you can see why this might look better, right? It doesn't have the render function anymore. It doesn't have the constructor that we didn't actually need. It's just a little bit simpler, a little bit neater. We're just returning the main stuff in the render. That is a great question, Vic. Where does the component did mount go if we are using function components? We're going to do this slightly differently. What about state? How do we do state in a function component? That's another thing that might have just disappeared. This is where we use something called hooks. The use state hooks is something that lets us magically have a state value in a function. Okay, so what's a hook? Well, I'm not going to go into detail, but really a hook is just a special function that you can only use inside of a function component in React. Okay, so let's see what that looks like. We're going to go to app.js. We're going to convert app.js to function component. So in this case, let's just change this to const app equals arrow function props. Okay. So the way we're going to use state is we're actually going to do something that looks like this. Const use state equals React. And that is going to import the use state function from React. Lets us use it. And then instead of having this initializer here, we're going to say const and then an array. So let's replace breed here. Breed, comma, set breed equals use state of the string that we want to initialize it to. Okay, so this argument is our initial value. And then these two things are actually, number one, the state value itself, and then number two, a function that lets you update the state value. So instead of using set state, this dot set state, as you would in a class component, in a function component, you're just going to have a function for every single possible value, state value, that is called set and that. So then the other thing we have is const iteration, and then we want to do set iteration equals use state, and in this case, our initial value from the constructor is 0. Okay, so that replaces, those two lines replace our entire constructor, which was like 8 lines. Okay, we need to add const here because now it's inside of a function, so we need to declare it as a variable. And then render, we're going to delete the render function, and then this just goes in the main component function. So a couple other differences. So breed and set breed. So to use the set, instead of using set state here, we're actually going to just call set breed. And we did event.target.value like that. And we can do set iteration in the same way. In this case, iteration plus 1. And that replaces our set state line. On this one, we're going to set iteration 1. That will replace this one. Cool. So that's all converted. And then the other big difference we need to do here is we need to get rid of the this because we're not in a class anymore. Okay. And now we have a function component. Oh, we can get rid of this line too. A function component. So in many fewer lines, we're actually doing the exact same thing. And hopefully if I did this right, dog generator, oh no. I forgot to get rid of this in good boy meter. Dog generator will still work exactly the same. The only difference is that we're using function components now. So the code might look a little bit nicer. Okay, I'm running a little bit low on time, so I'm gonna have to speed through this last part, but A couple rules of hooks that you should just know. You can look into the React documentation if you want to know more. But remember, hooks are the things like the use state function, and there's a ton of hooks out there. A lot of libraries will add custom hooks, but you can only call hooks at the top level. So never call a hook in an if statement, never call a hook in a for loop, etc. The reason for this is because of some internal stuff of how React handles hooks. You don't need to know the details, but yeah. Okay. The other rule of hooks is that you can only call hooks from other React functions. It must be either a function component or a different hook. So that actually alludes to something else. You can write your own hooks, which is kind of fancy. It can be a combination of other hooks that has even more logic. So something like the use navigate hook in Reach Router is actually just something that library implemented based on some other hooks that exist in React. Okay, now we're going to move on to Vic's original question, which was how do we do lifecycle things like component did mount? And this I'm going to speed through, but basically it all gets combined into a single thing called use effect. And the reason we didn't really teach you function components originally is mostly because this use effect thing can be kind of confusing and it requires a different way of thinking about the React lifecycle. So if we want to convert dog viewer, the actual dog viewer application, we're going to do the same thing we did earlier with state. So const use state. I'm actually going to import use effect as well here. And then we're going to do image link, use set image link, use state, empty string. I'm missing something here. Oh, okay. Const dog viewer props arrow function, and then loading set loading use state true. Okay, we can delete our constructor now. Okay, so this function, the way this component works is on component did mount, it fetches the dog. The way we're going to replace this in hooks and function components is using use effect. And this component actually is interesting because it uses component did mount and component did update. The reason it uses component did update is that if iteration changes, so basically in order to create the effect of when we press enter again, the breed hasn't changed. The breed prop is still the same, but when we press enter again, the iteration changes. And so we still want to reload a new dog. So basically all of these lines, 32 through 46 here, all they're doing is they're saying, if either iteration or breed changes, or we're initially mounting the component, so those are three different situations where you might want to call fetch dog. If any of those three things become true, we want to call fetch dog. Okay, we can replace all of that with hooks by just saying use effect. This is saying we're going to use just some effect. In this case, the effect is fetch dog. And then we're going to provide an array of dependencies. And this is telling React, okay, if any of these things in the array of dependencies changes, we're going to recall the effect, in this case, the function fetch dog. So we'll declare fetch dog as const and use effect fetch dog. And it's going to call that if either breed or iteration changes. And now we can just delete all of this code. We're going to delete this as well. And then the other thing we need to do at the beginning of, need to get rid of this here, where we need to set loading true here. And then we need to replace our set state here with set image link, set loading false. delete this set state. Okay, so theoretically, oh boy, breed is not defined. This should be props.breed, props.iteration. Okay, so theoretically, dog viewers should now work exactly the same. But we've substantially reduced our code, the number of lines of code physically. We've simplified some things because fetch dog, all of this logic is now contained in this single use effect line. And it's now a function component. So now we can sort of see some of the advantages of function components, how it simplified our code here. There's a bunch of other stuff about function components that I don't have time to get into now because you all probably need to get to lunch. But once you've converted your components to do functions and use hooks, then there's actually a bunch of these other hooks you can use. Use context is one of them. Use callback and use memo. If you're familiar with like 006 memoization, React does this kind of memoization too, and you can tell it explicitly to do this kind of memoization using use memo. Use ref. We talked about refs earlier, but refs are even easier to do when you're using function components using the hook. A couple other hooks that exist out there. And then hooks are composable, so you can write your own. So you can just write a function called use something that is a combination of any of these hooks. An example is you might want to combine use effect and use state. So let's say I wanted to write a hook that was like use dog. I could literally make a hook called use dog that would combine this use effect and this and the use state in app.js that sets the breed. And that hook could be the one that handles the state of which breed we're looking at. It would also handle the actual data fetching of the dog. And this kind of composability makes hooks a really powerful abstraction to use in React, and is a lot of the reason why function components were created in the first place. Cool. That's all I have for you today for the advanced React lecture. I hope you guys learned something. You should be good to go to lunch now. Otherwise, feel free to stick around and ask any questions if you have any.